Did you get the first 4 blanks on the pink notes correct? This goes with the parent graph. This graph right here is the graph of y equals x squared, and it's called the parent graph because this is the simplest possible parabola. These are your key points for this parabola. That's how I got these points right here on the graph. From this table, I got the table by taking that number and squaring it. That's what we did yesterday. Now we are going to take these. We did our translations yesterday, and today we're going to do reflections, stretches, and compressions. These rules are the same rules that we saw earlier in the year. This is just now applying them to the x squared type graph. So, when we look at example 1, the number 2 out in front, 2 out in front is a number bigger than 1. If the number is bigger than 1, it makes a vertical stretch. That 2 out in front makes a vertical stretch by 2. 2 is how much it's going to stretch it. What does the x minus 1 do? Alejandro, what does the minus 1 do? Perla, what does the 3 do? What? Oh, I didn't hear. Okay, and so on your homework paper, instead of having to write out the words, we've already written out the words and you just put the numbers in the correct place. So the first thing I need to do is put the vertex in the right place. Move the vertex from 0, 0, right 1, and up 3. So the vertex is at 1 and 3. The axis of symmetry goes through the vertex, and it crosses the x-axis at 1. So, how do I figure out the rest of the graph when there has been a stretch? It is a vertical stretch. Is that 2 in the parentheses with the x? It's outside of the parentheses, so that means it's not going to act on the x, it's going to act on the y. I am going to take these y numbers and multiply them by the stretch number. I think it's easier to do the stretches using the table. To move it left, right, up, and down, you don't necessarily need to use the table, but the stretches, it's really helpful to use the table. The x values are going to stay the same. The y values are going to multiply by 2. 4 times 2 is 8. 1 times 2, 0 times 2, 1 times 2, 4 times 2. Those numbers have been stretched vertically. But again, I'm not counting these numbers from 0, 0. I'm counting these numbers from my new vertex point. So I am going to count these numbers from my vertex point. I'm going to go over 2 and up 8, so it's going to go all the way off the top of my graph. I'm going to count these points right here from my new vertex point. I'm going to go left 1 and up 2. I'm going to count these points right here from my new vertex point. I'm going to go right 1 and up 2. I'm going to count these points right here from my new vertex point. I'm going to go over 2 and up 8, and that would go off the top of my graph paper. And so then I'm going to connect it, making a curve on the bottom. And those were kind of sorry looking arrows at the top. The arrows indicate that it continues, it doesn't stop, so you can't leave the arrows off. The arrows are part of a correct graph. The domain is the same on all parabolas. The arrows are pointing up. That means it continues to go to positive infinity. Hold on your question. And this point right here has a y value of 3. Now, the last thing we need to fill in is the function notation. When we have a CBA test in December, I do not write it. The district people write it, and I don't know whether they're going to write this kind of question in vertex form or in function notation form. That's why I have to show you both ways. In function notation, this is what the problem would look like in function notation. The 2 is still out in front. The x minus 1 is still in parentheses. Still have the plus 3 on the end. What is missing though? The squared. Because this could apply to any function, not just this one, but any function at all. And so that's called function notation, and this one is called vertex notation. Example number 2. What is the 1/2 out in front going to do? Shrink or compress, both words are acceptable. Compression by 1/2. Actually, a vertical compression by 1/2. Gilberto, what does the x plus 4 do? Eli, what does the minus 2 do? I'm going to do this part first when I set my vertex point. Starting at 0, 0, I'm going to go left 4 and down 2. And that's my vertex point. And so the vertex point is at -4, -2. The axis of symmetry goes through the vertex point and crosses the x-axis at -4. Now I'm going to do my compression. Do you see that the compression, the 1/2, is not in the parentheses with the x? That means it's going to act on the y. I am going to multiply these y numbers by 1/2. These x numbers are going to stay the same. Those numbers stay the same. What's half of 4? What's half of 1? 0.5. Half of 0 is still 0. Half of 1 is 0.5. Half of 4 is 2. But I'm not going to count these points from 0, 0. I'm going to count them from my new vertex point. I'm going to go over 2 to the left and up 2. I'm going to go to the left 1 and up 1/2. To the right 1 and up 1/2. Right 2 and up 2. And then I am going to make a curve. That parabola should look wider than the proper parabola, the parent graph parabola, because when you compress it vertically, it's going to make it spread out that way. Domain is the same. The arrows are pointing up. That is the minimum point the y value of this point right here is -2. In vertex form, that would be 1/2 x plus 4 squared minus 2. Instead of having the f indicating a function, it has the squared indicating specifically the parabola. On part C, what is a negative sign out in front going to do? The negative sign out in front is going to reflect over x. What's the x plus 1 going to do? What's the minus 1 going to do? This is what I'm going to do first. I am going to put my vertex point in the right place first. It starts at 0, 0, and it goes left 1 and down 1. And so my vertex point is at -1, -1. The axis of symmetry goes through the vertex point, and it will cross the x-axis at -1. Now, oh, wait. I forgot something in my transformations. I didn't write down what the 3 is going to do. What is the 3 going to do? Vertical stretch by 3. That -3 is out in front of the parentheses. It's not in the parentheses with the x, so it's going to act on the y. So I am going to multiply by -3, and that's going to take care of the stretch and the reflection at the same time. When I multiply by -3, it's going to do this and that, both at the same time. And so the x values are going to stay the same. What's 4 times -3? 1 times -3. 0 times -3. 1 times -3. 4 times -3. And these points I put over here in the table, I'm not counting them from 0, 0. I'm counting them from my vertex point. So I'm going to go over 2 and down 12, and that's going to go all the way off the graph paper. I'm going to go left 1 and down 3, so that's a point on my graph. Right here, I'm going to go right 1 and down 3, and that's going to be a point on my graph. I'm going to go right 2 and down 12, and that's going to go all the way off the bottom of my graph. And this is going to make a skinny little parabola, because that's what happens when you stretch it by 3. It makes it look pretty skinny. The domain is always the same. But does this one go to positive infinity? It is pointing down. So it is going to negative infinity because it's pointing down. And now this point right here is not at the bottom, it's at the top. The top point is at -1. If this point is now at the top, would it be called a minimum point? What would we call it if it's at the top? It would be a maximum point. And in vertex form, this would be -3 x plus 1 squared minus 1. That's how you would write the same thing in vertex form. But what if you have the graph? How can you write the graph? Well, the first thing that you need to know on the graph is the vertex. So in example 3a, where is the vertex? The vertex form is written over here on the board for you. The vertex form looks like this. So I'm going to come back to the A in a minute. I'm going to fill in the rest of it first. X minus 4 squared plus a negative 2, which would just be subtract 2. But minus a minus makes a, because X is a liar. If it is minus, it's actually plus 4 in the equation. Now, don't write this part in your notes. I just want to ask you if you remember, what does M stand for? Slope. How do you find slope? Do you remember that part? Okay, this is what you have to write in your notes because it's not there, and you need to write this part in your notes because this is the most important part of the lesson and it wasn't written in your notes. What we need to figure out now is the A. The A is not equal to rise over run. That's for a line. For a quadratic, the A is equal to rise over run squared. Do we all know how to find rise over run? For a quadratic, the A is equal to rise over run squared. Be sure to write this in your notes and write it big because this is the most important part of your notes today. So, to find the A, what is the rise? What is the run? And I found a pretty point over here that would be easy to count. That's not A. A is rise over run squared. Because of order of operation, we don't have any parentheses, so the first thing we do is exponents. What is 2 squared? What is 2 over 4? And so this is 1/2. The A is 1/2. That's not too hard to figure out if you know this little equation. So in function notation, the 1/2 goes out in front, x plus 4 minus 2. First thing I need to know to write the equation in vertex form is the vertex. So what is the vertex? 1 and 3. So y equals x minus 1 squared plus 3. Do you notice that the graph is pointing down? If the graph is pointing down, there will be a negative sign right there because the graph is pointing down. And A is equal to rise over run squared. So here's a pretty point. Here's the rise. Here's the run. How much is that? How much is that? It's 2. A equals 2 over 1 squared. What's 1 squared? But what if you used a different point? What if I use this pretty point right down here? Would I get a different number? I need to make sure that I go all the way back to the vertex, though. What is the rise here? The rise here would be 8. The run here would be 2. What's 2 squared? 4. What's 8 divided by 4? So we get the same answer as long as we remember to count all the way back to the vertex. So in function notation, this is what it would look like.